Hi, in this lecture we will see the set data type in Python. In the data type lecture we saw some collection of elements, right? There are some data types which store a group or collection of elements, which were strings, list, tuple, set and dictionary. We have already seen string, list and tuple in detail. In this lecture we will see the set data type, how it works, how to create set and what are the important methods which are available on set data type in Python. So let's start. Firstly, introduction to set. What is a set? A set is a built-in data type in Python used to store unordered, unindexed and unique elements. Okay, there are a few properties of a set. It is also a collection of elements and it is unordered. So this is the first data type that we are seeing, which is unordered. Till now, whatever data type which we have seen, which is a string, list or tuple, they were all ordered, in which there was a sequence. We can say this is the first element, this is the second element and so on. But in set you cannot do that. In a set is unordered and there is no indexing or position in a set. You cannot say this is the first element or second element. And this follows the mathematical notion of set as well. In maths, when we say what is a set, in set there is no position. There are just unique elements present. There are no duplicates. So same concept is followed in programming language Python as well. When you create a set, it is unordered, unindexed and it will only contain unique elements. It cannot contain duplicates. So what are the characteristics? First is unordered. Elements don't have a definite sequence. You will not have a definite sequence. They are mutable. Okay, like list, they are mutable. Strings and tuples were immutable, but sets and lists are mutable. You once created, it can be changed. So you can add elements to a set. You can remove elements from the set in place at the same memory location if you want. A set is mutable. It is heterogeneous. So almost all collections in Python are heterogeneous. Except strings. Strings are only a sequence of characters. Except that, like list, tuple, set, dictionary, they are all heterogeneous, which means a single set, the same set can contain an integer, a floating point number, a boolean value, different data types in a same set. So it can contain different data types in the same set. It is unindexed, which means elements don't have an index or position. Strings, list, tuple, whatever we have seen till now, everyone had a indexing. And they were ordered, but set is the first data type that we are seeing, which is unordered and it is unindexed, which means you cannot access an element using its index. There is no concept of index in set. So elements cannot be accessed by their position. And unique. So all the elements in a set must be unique. Duplicates are automatically removed in sets. If you add duplicates, they will be ignored, they will be removed. Only unique elements will be present in a set in Python. So how do we create sets? Set in Python is created using curly brackets like this. In curly brackets. This is used for set. Till now we have seen a string can be created using single quotes, double quotes, triple quotes like this. Right? Strings can be created using single, double or triple quotes. And square brackets are used to create list. And round brackets or parentheses are used to create tuples. And in keyboard we have three kinds of brackets. This is the third one. So curly brackets are used to create sets. Okay. So if you add any number of elements inside a curly bracket, comma separated, just like list or tuple, it will create a set containing 3 elements. The only thing is, in every lecture we used to start with an empty tuple or empty list. So if you just create like this will be an empty list. If you don't add any element. And if you create just round brackets, it will be an empty tuple if you don't add any elements. But if you create like this is not used to create an empty set. In the next lecture, we will see what it does. Okay, because dictionary and set both are created using curly brackets in Python. That is why it will be ambiguous. It will be ambiguous for the compiler what you are trying to do here. And if you just create curly bracket, opening curly bracket and closing curly bracket, and if you don't add any element, it is not used to create an empty set. And that is why we have not mentioned here. If you want to create an empty set in Python, you have to use the set constructor or the set method. There is no other way, okay? So you cannot create an empty set just using curly brackets. Empty list and empty tuple can be created, but empty set cannot be. But if you want to add some element, even if you want to add a single element, that can be done. Single element or multiple elements, that can be added in curly brackets, but an empty set cannot be created using curly brackets. Okay. So a set can contain same type of elements like integer, 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 or a set can contain heterogeneous elements, which means different type of elements as well. So here we have an integer, a string, a floating point number, and a boolean value. So if you add these 4 values in a set, what will happen? There is one catch here. True, actually boolean values are a subclass of integer, and true internally is considered as 1 only, and 1 is already present in the set. So when you create a set like this, true will be automatically removed and only 1, hello, and 3.14 will be there. Because internally true is considered as 1. So if 1 is already present, this will be removed and only 1, hello, and 3.14 will be present. But the point is, a set can contain heterogeneous elements, which means different data types in the same set, it is allowed. Okay, so this is how you can create set. Now if you want to create a set using the set constructor, you can do that. Just like list and tuple, we have a set function. Python provides a built-in function set that creates a new set from any iterable. You just need to provide it an iterable and it will create a set out of it. So the syntax is set, and in the brackets you have to provide an iterable. Now a string is an iterable, a list is an iterable, tuple is an iterable, even set is an iterable. Okay, so you can provide anything inside it and it will create a set out of it. So if you just write like this, set, and inside here we have an iterable, let's say list. So now it will convert this list into a set. So now you will have a set containing elements 1, 2, and 3. Okay, so this is how you can convert any other iterable into a set using the set constructor. And if no argument is provided, it returns an empty set. So if you provide no argument to the set function, it will give you an empty set. This is how you can create an empty set in Python. You cannot do it using curly brackets. If you have to create an empty set, you have to use the set constructor, and you can like not provide any argument and it will create an empty set. So if you print empty, the output will be set. It will not print curly brackets because curly brackets are not used to create an empty set. Empty set in Python is always represented like this, set, like this. This is how you represent an empty set, okay? Because you cannot use just the curly brackets to represent an empty set, okay? So you can create an empty set like this and output will be set, which means it is an empty set. And even if you pass an empty iterable, that will also work. Let's say I pass an empty list. This will also create an empty set. This and this are equal because here the iterable was empty. So when you convert it into a set, it will be an empty set. Okay. So this is how you can create an empty set or any set using the set constructor in Python. So now let's say you have a string S containing characters gate. S is the string containing characters GATE. We know that string is a iterable. It has an index, it is an iterable. It can give all its elements one by one. So when you say chars variable is set of S, so it will convert all the elements in this string, which is an iterable, one by one, and it will insert in the set. Now when you print chars, that's where set differs. So set does not have any order. So when you print the elements of a set, they can actually come out in any order. There is no guarantee. Even if you do it multiple times, if you print the same set multiple times, your output order can change. Okay, so like it might be possible that you are getting GTE, GTAE like this, or even like some other order can be printed like AE, GT. This is also possible. So they can actually come out in any order. Order is not guaranteed. So it is not that G will only come as the first character. Every time when you run it, a new order might happen. Okay, and here right now there were no duplicates. There were no duplicates and hence it can contain unique items. But let's say you do it for a different string. Let's say if you create a set using some different string instead of gate, what if we have the string banana? And if you create a set out of it, now the characters set will contain only the elements B, A, N. Now A is already present, so it will be ignored. N is already present, so it will be ignored. A is already present, so it will be ignored. Only these three characters will be present inside the set. It can only contain unique elements. Since A and A were already there, the duplicates will be removed. Only unique elements will be present in the set. So when you print chars, this will be the output, and the length of the chars, which means the number of elements inside this set, will be 3. There are only 3 unique elements. And order again can be different. If you're printing cards, you can have N, A, B, A and B, any order. Order is not guaranteed. So output can be G, E, T, A. Any output can be there, okay? So order is not guaranteed. Now similarly, let's say you have range 1, 5. Range 1, 5 is an iterable. Range 1, 5 is an iterable. Step size is not given, so step size is 1, start is 1 and stop is 5. So it means it can take values 1, 2, 3 and 4. Stopping point is exclusive. Now you are just entering all these iterable values inside a set. If you say set range 1, 5, it will convert this iterable into a set, which means the values 1, 2, 3, 4 will be inserted in a set. When you print this set, order again is not guaranteed. You might have 3, 1, 2, 4, or you can have 1, 2, 3, 4, any order. So order is not guaranteed, but the set will contain the elements 1, 2, 3 and 4. Okay, so this is how you can create set using the set constructor. You just have to give it any iterable and it will convert it into a set. Now let's see how we can loop through all the elements in a set. So we can loop through elements of a set using for loop. I told you for loop only works on iterables. We need an iterable. Now so far what are iterable we have seen? String is an iterable, it gives its characters one by one. Lists are iterables. Tuples are iterables. And they all were ordered. They all were ordered. Which means you will have first element, then second element, then third element and so on. And even the range function. The range function is also an iterable and it is also ordered. You will have first element as the starting point, then next element and so on. So they are all ordered. They have an index. They have order, like this is the first element, then second element and third element. So these iterables give the values in that order. But an iterable can be unordered as well. So set is also an iterable in Python, but it is an unordered iterable. So iterables can be unordered as well. And set is an unordered iterable, which means it will also give its elements one by one. So let's say a set contains elements 1, 2 and 3. When I iterate over all the elements of this set, I can iterate like at 1, then 2, then 3. Right? So it will, as an iterable, it will give all its elements one by one, but the order is not guaranteed. You might get 2, then 3, then 1. So when you are applying a for loop on a set, the order in which the elements will be accessed is not guaranteed, but all the elements will be accessed exactly once. It is an iterable. It is not that it will give 1 and then again 1. So the next element is not independent of the first element. You will access all the elements exactly once. It's just that the order is not guaranteed. So you might get 2, 3 and then 1, or you might get 3, 2 and then 1. The order can be anything, but as an iterable, when you iterate over a set, you will get all the elements one by one. And the order can be anything. You cannot guarantee it. You can never say that this element will come first while iterating. It is possible that in the same set, when you're iterating the second time, the order is different now. Okay? But it is not like when you're iterating, it will not be the case that you are iterating 2 and then again you will iterate, like the atom will take the value 2. No. If you have taken the value 2, now you will take either 3 or 1. Then you can take the remaining values. So exactly once all the values will be covered. Okay. So it acts as an iterable. It's just that the order is not guaranteed. It is unordered. So let's say you have a set containing strings. String apple, string banana and string cherry. You can create a set containing strings. And you can iterate over it as well. So if you write for fruit in fruits, so the fruit variable will take fruits inside this set. Again, the order is not guaranteed. When you run it, the output can be cherry, apple, and then banana. Although the set contained apple, banana, and cherry, but when you are iterating over it, the order is not guaranteed. You might get cherry and then apple and then banana, or any other order is also possible. So you can iterate using a for loop because sets are iterables, they are unordered iterables. Okay, and we have not seen, see if you notice that in list lecture, in string lecture, in list lecture, in string lecture, and in even tuple lecture, we saw some concepts. We saw concept of indexing and we saw the concept of slicing. These concepts are not there for sets. These concepts don't even exist for set because in set there is no order, there is no indexing. You cannot access an element using its index. If you write S of 0, you will get an error. If this is your set, if S is a set, let's say S is the set 1, 2, 3, then you cannot say S of 0. You cannot even print it. Like change is a different thing. You cannot even print it because an element cannot be accessed using its index. There is no concept of index in set. So that is why we have not seen indexing in sets and even slicing. Because there are no indices. You cannot write S of 1, 2, 2. This is not possible. So on sets, indexing and slicing is not there. Okay? Because they are unordered. And that is why you cannot use a while loop to iterate over sets. There are ways in which you can use while loop, but when we saw list and tuple lecture, we were using index in the while loop. We were saying I is equal to 0, and if I is less than length of the list, we were doing something like this, and then we were printing list of I. So we were actually using the index. We were actually using the index to iterate over a list or a tuple or a string. But in sets, we don't have indices. And that is why it will be very difficult to use a while loop to iterate over a set. You can use a for loop because it is iterable, but using while loop, it will be difficult. Okay? But you can use the enumerate function. Enumerate function only accepts a iterable. It can be an unordered iterable as well. You can use an enumerate function with a set, but it is not suggested. It is not suggested to use the enumerate function with a set or using a set as an iterable. The reason is because let's say you create a set called animals and the values are cat, dog and lion. The strings cat, dog and lion. What does enumerate function do? Enumerate function takes all the values of the iterable. This is our iterable and it is a set, which means it is an unordered iterable. So it will take all the elements, all the values inside the iterable and it will give you tuples, index comma value, and then index comma value, and then index comma value. It will work, but again the order is not guaranteed. You might get some other index when you are running it again. You run the same program again, but index and value tuples might change. And that is why there is no consistency, and that is why it is not suggested to use. But if you want, you can use it. You might get the output as 0, dog, and then 1, lion, and then 2, cat, or you can get it in any order. There is no guarantee. So you can run it and you can say index, animal, tuple packing and unpacking will happen. Index will take these values, animal will take these values. So you might get output as 0, dog, 1, lion, 2, cat, or in any other order as well. Okay, the values might be different in every iteration whenever you are running. So order is not guaranteed, and that is why that is what you need to know in sets when using for loop normally or even with using enumerate. Okay. Now let's look at some mathematical operations on sets. So what all operators we can apply on sets? Let's see that. We have seen addition operator in list and tuple that is used for concatenation. But in set, addition operator is not allowed. You cannot add two sets. This is wrong. You cannot do that. This is not even possible. So we used to do concatenation of list, tuples and strings using addition operator. So addition or concatenation can only happen on ordered sequences. Concatenation can only happen on ordered sequences. Why? Because when you are concatenating, you need a sequence, right? What does concatenation do? Let's say you are adding two lists. It creates another list in which you add all these elements in the first and then you add all these elements. Right? This is what concatenation is. You firstly add all these elements in an order and then you add all these elements in an order. And same thing happens with the string and tuple as well. But you cannot do it for sets because sets don't have an order. So there is no concept of concatenation in sets. You cannot concatenate sets. But you can take union of sets. Think about it. Set as a mathematical symbol has an operation called union. You cannot concatenate two sets. But you can take the union of two sets. What is union of two sets? It contains all the elements in first set and second set both. All the unique elements. So if the first set contains elements 1, 2, 3 and the second set contains elements 2, 3, 4. Then their union is the set containing all the unique elements in first and second set both, which means 1, 2, 3 and 4. Right? This is the simple set theory that we see in maths. So that you can do. So union operation is allowed, but concatenation doesn't make sense. So that is why addition operator is not there. Even multiplication operator is not there. There is no sense of 1, 2 into 3. Like this is not allowed because you cannot have same elements again anyway. So this is not there. So multiplication and addition are not there. But you can take union, intersection. Intersection means what? Intersection means all the common elements between the first and second set. So that is also there. You can do intersection. The intersection will be 2 and 3 because they are present in both the sets. So set difference, union, intersection, all the mathematical operators which are there on sets in maths can be applied on sets in Python as well. So if you have to take union of two sets, you can use the bitwise OR operator. This is crazy. If you use this operator on two integers, it will calculate bitwise OR, right? The pipe operator. But if you use it on two tuples, if you use it on two sets, then it will do something else. It will calculate the union. So if you use it on integers, it calculates bitwise OR. And if you think about it, somehow it is calculating OR only, this set or this set, which means a set containing elements of both of them, right? So bitwise OR operator, if you apply it on sets, it will do union. It will calculate the union of these two sets. So another set will be created, a new set will be created which contains all the elements in the first set and second set. And if there are duplicates like this 1, 2, 3 and 2, 3, 4, and if you do an OR between these two, this set will be the answer because duplicates are not allowed. So the answer will be the union of these two sets. And if you want to calculate intersection, you can use the bitwise AND operator. Bitwise OR operator is used to calculate the union of two sets. Bitwise AND operator is used to calculate the intersection between two sets. Why am I calling this bitwise OR and bitwise AND? Because for integers we have seen operators lecture, right? There we have seen these are used for bitwise AND and bitwise OR. Okay? But on sets, they are used for union and intersection. So AND is used to calculate this set and this set, which means elements which are present in both the sets. So it is intersection, which means the only element which is present in both of them is 2. So 2 will be the answer. Okay. Now if you want to calculate set difference, you can actually subtract set 1 minus set 2. So minus operator is allowed on sets. Minus operator is not allowed on list or tuples or strings. But minus operator is allowed on sets. You can subtract a set from another set and it will just calculate the set difference. So what is set difference? In mathematics, set S1 minus set S2, it will create a set containing all the elements in S1 which are not in S2. Which are not in S2. This is how you calculate set difference. S1 minus S2 means another set which contains all the elements in S1 which are actually not present in S2. You can write it like this as well. It is nothing but S1 minus S1 intersection S2. This is standard set theory. If you know Venn diagrams, this is standard set theory. S1 minus S2 is what? Contains all the elements in S1 which are not in S2. Okay? Cool. So, if you do the difference between these two, so it will contain all the elements in the first set which are not there in second set. So 2 and 3 will not be there, only 1 will be the output. This is how you can calculate set difference. Next is symmetric difference. Symmetric difference means S1 minus S2 union S2 minus S1. Symmetric difference. Symmetric difference between two sets means S1 minus S2 union S2 minus S1. Which means all the elements in first set which are not there in second set and all the elements in second set which are not there in first set, both of them. So all the elements in first set which are not there in second set, which is only the element 1, and all the elements in second set which are not there in the first set, which means the element 3. So you will get the elements 1 and 3. And this is nothing but the union of both the sets minus the intersection of both the sets. If you think about it, it is nothing but the union of both the sets and you just remove the elements which are there in both the sets. Okay. Again, like I'll not explain the set theory, that you can like read in the set theory, like you probably already know set theory. Let's not cover that in detail. But yeah, this is what symmetric difference does. So you can use the bitwise XOR. This is the bitwise XOR symbol. If you use that symbol between two sets, it will calculate the symmetric difference between them. Okay, or the power symbol. And then we have membership, very simple, in and not in. It will just tell you that that particular element is present in the set or not. So 2 in 1, 2, 3 means 2 is present in here or not. 2 is present, so you will get true. And if you write 2 not in this, you will get false. Not in is opposite of in. So membership operator is simple. Then length function is also simple. Length function tells us how many unique elements are present in that set, right? How many elements are there? So in this set there are 3 elements. If you say len of set containing 1, 1, let's say you ask like this, length of set containing 1, 1, 2, 2, 3. So when you create this set, automatically duplicates will be removed. So 1, 2, 3 will be there. So automatically the length will be 3 only. Set can only have unique elements. Always remember that. So the length function tells us how many elements are there in the set. Then min, max and sum function we have already seen for list and tuples. Same way it can work for sets as well. If you want to find the minimum element present in a set, maximum element in a set, or sum of all the elements in the set, you can use the min, max or sum function. On sets as well, it will give you the minimum element. Min function, max function gives you the maximum element, and sum function gives you the sum of all the elements. So here there is a very important example. Sum of the set 1, 2, 3, 3. What will happen here? Sum of the set containing 1, 2, 3, 3. Now a set containing 1, 2, 3, 3 cannot exist. Whenever you write this statement internally, the set will only contain 1, 2 and 3. You might think that the sum of all the elements here is 6, 7, 8, 9. You might think that the sum of elements present here is 9. But it is not the case. Internally, when you create a set like this, duplicates are all automatically removed. So the compiler will automatically convert this set into this set. In memory, only this set will be present. This set is not present at all. So when you are calculating sum of this set, you are actually calculating the sum of this set. And hence the answer will be 3 plus 2 plus 1, which is 6. So answer will be 6. Although the sum of these elements is 9, but they are not all present in the set. Set contains only unique elements, and hence the answer will be 6. Very important example here. So this example can be applied on sum as well, and even for length. Length function also, remember that if you have duplicate elements, length function will shrink it and only calculate the number of unique elements in the set. So for this set, the length will be 1, 2, 3, 3. The length will be 3 elements only, not 4, because the number of unique elements is only 3, 1, 2 and 3. Okay. So this is how the different functions work on sets. Now let's see how the comparison operators work with sets. So in strings, list and tuple, we have seen if you compare 2 lists or 2 tuples or 2 strings, they are compared in lexicographical order, which means it will be comparing the first element. If it is equal, then it will compare the second element and so on till the equality is checked. So for example, if I compare list 3, 4 is less than or equal to, let's say 3, 5. So what it does, it will firstly see the first element is 3 less than equal to 3. Actually 3 and 3 are equal. So it will go to the next element. So now is 4 less than equal to 5? 4 is less than equal to 5. So it will give you right, true answer. Okay. And let's say if you say 3, 6 is less than or equal to 3, 5. So here what will happen? It will firstly compare the first element. Since they are equal, now it will compare the second element. Now 6 is not less than or equal to 5. So it will firstly find the first non-equal element and then compare that. So this is what happened in strings, list and tuples, all 3 of them. But comparison operators work differently on sets. Because in sets, there is no order, right? In a set, there is no order. You cannot say you are comparing the first element of both of them. And that is why comparison operators equal, less than, equal to, not equal to, all of them work differently in sets. In set, they check subset or supersets. Okay, we know sets have a property of subsets and superset, what they are. If you have a set containing elements 1, 2 and 3, a subset is a set containing few of these elements, few or all. So 1, 2, 3 is also a subset of this set, and even 1, 2 is a subset, even the empty set is a subset, like that. And we call this set as superset and we call this as subset. And the set which is exactly equal is not a proper subset. So what happens is there are 2 concepts here. So for 1, 2 and 3, 1 2 which is 1 comma 2, this is a proper subset. This is called a proper subset, which means like it is not equal to that set, it is a proper subset. It is like less than symbol. And you can have a normal subset, means it is a subset, or equal to is also possible. So if you say 1 comma 2 comma 3, 1 comma 2 comma 3 is also a subset of this set. 1 comma 2 comma 3 is a subset of this set, but it is not a proper subset. For it to be a proper subset, at least one element should be missing. Okay, so here less than, greater than symbols actually check subsets and superset. Okay, so what will happen? Firstly, equality. Like when are two sets equal? When they contain exactly same elements. So let's say a set containing elements 1 comma 2 is equal to the set containing elements 1 comma 2. Now in one of the sets you can have more 1 and 2 also, because this set is nothing but the set containing 1 and 2. Internally, this set is nothing, it is nothing but the set containing 1 and 2, and that's why this and this are equal. And order doesn't matter. You can even have set containing 1 comma 2 and that is equal to the set containing 2 and 1, because they exactly contain the same elements. Okay, so order doesn't matter. Like if the elements are same, then the sets are equal, and that is how you can calculate not equal to as well. That is just the opposite of that. So equality is easy. Now for less than symbol, it will just compare that the left side is a proper subset of right side or not. Proper subset, which means at least one element should be missing, and all elements present here should be here. So 1 comma 2 is a proper subset of 1 2 3, and you just have to convert this like less than symbol into the subset symbol. And here you have subset equal to, which means normal subset, right? And here you have superset, proper superset, and here you have normal superset. So just like you can easily convert them, right? Just see the sign, like it is like this, so you can convert it into this. So it is like this is proper subset of this set or not. So this is a proper subset of this set, so you will get true. But if you do this 1 comma 2 comma 3 is less than less than 1 comma 2 comma 3, so it is not a proper subset, right? It is actually equal. It is not a proper subset, so you will get false, like that. And here you are just checking normal subset, and here you are checking superset, which means this set contains, like it is just the opposite of that. So this set is a subset of this set or not, proper subset. And here the right hand side set is a subset of left side or not. Okay, so this is how you can check subset and superset properties using the less than and greater than operators in Python on sets. So the comparison operators work differently in list, strings and tuples, and for sets it is different. Okay. Now next we have methods that can modify the set. Now set is a mutable data type. In set you can add or remove elements, but there is no indexing, right? So if a set contains, let's say 3 elements 1 2 and 3, then you cannot say s of 1 is equal to 5, because there is no concept of 1, there is no indexing. So you cannot change elements like that. And you can, but you can add or delete elements. So if I have to change this 1 to 5, you can say I want to remove 1 from this set and I want to add 5. This is the way you can do it. So there are ways in which we can remove elements from a set and we can add elements to a set, that we can do. So let's see that. First is add function. Add function adds a single element to the set. If you want to add a single element inside the set, you can use the add function. S is equal to 1 comma 2. You do s dot add 3, which means inside the set we are adding the element 3 as well. When you print it, elements 1 2 3 will be printed. Again, order is not guaranteed. Whenever you are printing a set, order can be different, 2 1 3 3 1 2, anything. And in the same set, let's say you say right now the set contains elements 1 2 and 3. If you again say s dot add 2, now 2 is already there, so the set will remain same as it is. If you say s dot add string containing hello, then it will be added. Now if you print s, you might get any order. Let's say firstly you get 2, then 3, then string containing hello, then 1. There are 4 elements. They can come in any order. That's how you can add elements to the set. Add function, you can just give a single element and that will be added. Okay. Now next is update. Update function adds multiple elements to a set. So if you want to add multiple elements, let's say a list containing 1, 2 and 3. You want to add every element inside a list in a set. You can do that. So it is like the extend function in list. In list we had an extend function, right? In list we had append function. List dot append. that is equivalent in set. In set you can do set dot add. So for list we have append, in set we have add, they are same. And in list we had extend function, iterable, we give it an iterable. And here in set we have update function. Update function adds all the elements present in an iterable inside the set. So if you have multiple elements to add, you can use the update function. So it adds multiple elements from an iterable. An iterable can be a list, a set, a tuple, string, anything, okay, a range function, any iterable. You can pass it any iterable and it will add all the elements inside the iterable in the set. So if the set contains elements 1 and 2, and if you add elements 3 and 4 as well. So here, this is not a single element. Always remember that update function takes an iterable. Append function add function only takes a single element. So if you do s.add list containing 1, 2, what will happen? We will see. Actually, you cannot add a list in a set. We will see this thing. This is not allowed. But even for a string, let's say, if you do s.add string containing hello, so a single element hello will be added in the set. But if you do s.update string containing hello, here what will happen? This string will be treated as an iterable. Update function always takes an iterable. So here h will be added, e will be added, l will be added, l will be added, o will be added. Okay, so we can have a detailed example on this as well. Let's see how it works. So let us take an example, a tricky example. So let's say a set contains 2 elements, 1 and 2. And if I say s.add string containing hello, so what will happen? Now add function takes it as a single element. This is an element. Add function only takes a single element. So the entire string is treated as an element and this will be added in this set. So now the set will contain 1, 2 and the string containing h, e, l, l, o, a single element. This is a single element. So length of this set right now is 3. There are 3 elements, 1, 2 and hello. Now if you do in the same set, if you do s.update hello, what will happen? Update function takes an iterable, which means all the elements inside this iterable will be added. What are the elements inside this iterable? String h, string small e, string small l, string small l and string o. These are the elements inside this iterable, right? A string as a iterable gives all its characters 1 by 1. So all these elements will be added in the set. So now the set will contain elements 1, 2, hello, these were already there. And now string containing h will be added, string containing e will be added, string containing l will be added. String containing l is already there. It is already present, so this will be ignored. Duplicates are not allowed. So this l will not be added and then string containing o. So these will be the elements in the set now. So what is the length of this set now? 1, 2, 3, 4, 5, 6, 7. There are 7 elements, 2 integers and 5 strings. This is how the update function works. Update function will add an iterable, all the elements inside the iterable in the set. Okay? Cool. And add function adds a particular element. So when you are giving an iterable can be anything, an iterable can be a list, a tuple, anything. But when you are adding an element, this element cannot be a list. Why it cannot be a list, we will see shortly in the coming slides. You cannot add a list in a set. Okay, we will see that how. Okay, now if you write s.update string containing ABC, in the same set 1, 2, 3, 4 are already there. So characters A, B and C will also be added. So now it will contain 1, 2, 4, 3, C, B, A. Order doesn't matter, order can be anything. You can, like when you print it, the order can be anything, okay? So this is how the update function works. It will take an iterable. Now we have remove function. Remove function removes an element from a set. So if the set contains elements 1, 2 and 3, if you do s.remove 2, 2 will be removed from the set. And now if you print the set, only the elements 1 and 3 will be printed. Now if I give you another example, let's say the set contains elements 1, 1, 2, 3, 3. And if I say s.remove 1, and if I say print s, What are the elements that will be printed? You try to think first. So when you create a set like this, internally duplicates are already removed. So internally the set will only contain the elements 1, 2 and 3 in memory. Okay, in memory only 1, 2 and 3 will be present. When you do s dot remove 1, 1 will be removed, and when you print s, only the elements 2 and 3 will be printed. The order can be anything. So it can be either 3, 2 or 2, 3, but there will be only 2 elements in the set. Okay. So this is how the remove function works, and it will raise a key error if the element does not exist. So if the element doesn't exist, it will raise an error, program will stop. The same thing happens in list and tuple as well. You have to use the remove function very carefully, okay? And to avoid errors, you can write like this: if x in set, then only remove x, s dot remove x. So here x is an element, s is a set. So you are first checking if the element is present in set, then only remove it. This program will not give you an error. This is an error-free code. So if the element is present, then only you will remove it. If the element is not there, you will not even run it, you will come out. So if you want an error-free code, always check first. You can wrap it in a if loop, if condition, okay? Now next is discard function. So there is another way in sets in which you can avoid the error. Discard function and remove function are exactly same. They will remove the elements. The remove function gives you an error if the element is not present. But the discard function does not give you an error. It will just ignore the statement if the element is not present. So if you don't want errors, you can use the discard function. It also removes an elements from the set. So if you do s equal to 1, 2, 3, there are 3 elements. And if you do s dot discard 5, now 5 is not present in the set, but it will not give you an error. This statement will not do anything. Because 5 is not there in the set, it will not remove anything. When you print s, still the same elements will be there. So discard function and remove are same, but discard function does not raise an error if the element is missing. It will just ignore the statement, okay? So you can use the discard function as well. Remove, discard. And next is pop function. Now pop function in list does what? Pop function in a list can be used in 2 ways. You can either use it directly or you can use it with an index. So if you use it with an index, the element at this index will be removed and it will be returned, right? So it will be removed and returned. And if you use it directly, the last element will be removed and returned. So that returned means the entire expression will be replaced by the element which is deleted. And if you give it an index, ith element, which means index I element, will be removed and it will be returned. Now in set there is no concept of index. So this syntax is not allowed in sets. There is no index. But this is allowed. In set you can use the pop function. You can do a pop on sets. And since lists are mutable, that's why we had these functions. And sets are also mutable, which means at the same memory location everything is happening. Even when you were doing add and discard and remove, it was happening at the same memory location. Everything was in place till now. So if you have an empty set, let's say s equal to an empty set. So a memory location at, let's say, memory location 123, an empty set will be created. S will be pointing here. It is a set. Right now it is not containing any elements. It is empty. Now when you do s dot add 3, so 3 will be added in this set in place. Okay. When you do s dot add 7 will be added in this set. Now here order doesn't matter. So this is not how in memory they are stored. Internally sets are created using a very complex data structure that we will see in DSA. Okay, actually adding elements and removing elements from set is very easy. It's a very cost-effective solution. But how internally sets and lists work, what are the differences as compared to time complexity, that we will see in algorithms. Okay, not here. So internally they are not stored like this. They are stored in a different data structure, which is like heaps or something like that. So how are they stored, that we will see in data structures. But for now, just assume that let's say this is how they are stored. Okay. So 3 is present and 7 is present. Or let me make it like this. So it is a set containing the elements 3 and 7 right now. Now when you do s dot remove 3, Again 3 will be removed from the same memory location. So everything is happening in place at the same memory location, just like list. This was not possible in string or tuple. That's why we didn't have these methods in string or tuple. But in list and set, we have add, remove, pop, these kind of functions. So what will pop function do? Here in set, in list it removes the last element, but in set it will remove a random element. This is crazy. You don't have control over it. It will just remove a random element from the set. This, like, I don't know why they created it, but yeah. So if you do s equal to 1, 2, 3, if you do s dot pop, you don't even know which element will be removed. Some element will be removed. Now, if you print s, anything can happen. Like, it might be possible that 2 was removed, or 3 was removed, or 1 was removed. Let's say 1 was removed. So you might get 3, 2. But the good thing is, at least the pop function tells us what it removed. You can print the output of a pop statement. You can print it here. So after popping, it returns the value as well. So the entire statement will be replaced with the value that was removed. So you can see actually what value was removed, but actually it removes a random element. You don't have control over it. So if you have s equal to 10, 20, 30, and if you do element is equal to s dot pop, so one element will be removed. You don't know what element it will be, but let's say whatever element that was removed, that is stored in the variable lm. Now when you print lm and s, you can print which element was removed and what is the set now. So here 10 was removed, and hence the set contains 20 and 30 now. And the order is arbitrary. When you apply a pop function, any random element might be removed. Okay. When you are running it again, something else might happen. Okay. This is how the pop function works. Next is clear function. Clear function removes all elements from a set, just like list. In list also we had a clear function. In set also we have clear function. In tuple and string we don't have clear function because they are immutable. We cannot clear a tuple. Tuple once created in place, it cannot be cleared. But list and sets are mutable. It's very simple, right? All the functions which are there on set are there in list as well, because they are both mutable. They have similar properties, and that is why they have similar functions. So what will clear function do? If s is equal to 1, 2, 3, it contains 3 elements. Now when you do s dot clear, at the same memory location, whatever is present, everything will be deleted. Now s will become an empty set. Now s will become an empty set. Okay. So when you print s after s dot clear, an empty set will be printed. At the same memory location, everything will happen. So these were all the methods to add elements and remove elements from a set. Okay, now let's look at sorting a set. So what do we mean by sorting a set? See, set doesn't have an order. And when I say sorting a set, it doesn't make sense, because if you sort a set in place, it doesn't make sense. Let's say a set contains elements 1, 2, 3. There is no order. When you print it, it might be 2, 3, 1, 3, 1, 2, anything. If you sort it, it will remain same, right? Like even if you sort it and you print it, again the order might be different. So there is no point in sorting a set in place. And that is why in list we had a dot sort function that sorts a list in place, which means at the same memory location. But for set, there is no sort function because it doesn't make sense. Right? You cannot sort a set in place. Okay? But what if you want the elements of a set sorted in a list? Let's say a set contains elements 3, 1, 5, 2, 4. You don't have an order right now, but you want to calculate an ordered list which contains all the elements sorted. Then you can use the sorted function. Sorted function takes any iterable. You can pass any iterable to it, and set is also an iterable. So if a set contains elements 4 to 7, and if you pass it in the sorted function, then the nums2 will be a list. It always returns a sorted list. Even if you pass a tuple, it will give you a list. So nums2 will be a list containing the elements which are in sorted way, 2, 4, 7. And if you pass the same set in sorted with reverse is equal to true, now the elements will be sorted in a reverse manner, and that will be given to nums2 as a list 7, 4, 2. So that is how you can use the sorted function. Dot sort function is not available in sets because it doesn't make sense to sort a set in place because there is no ordering in sets in general. Okay. Okay, now let's look at set algebra methods. So we already have seen what union, intersection, difference and symmetric difference mean, right? If you want to calculate union of two sets, which means S1 union S2, it means all the elements which are there in S1 and S2 both and if you do S1 intersection S2, it means all the elements which are there in S1 and S2 both, right? So which means here the elements which are present in both S1 and S2, and here you will get the elements which are in S1 or in S2. So this is like OR. So you can use the bitwise OR operator to do this, bitwise and then S1 minus S2 can be done with the minus operator, and then bitwise exclusive OR operator can also be used, which is the power operator. So you can use this to calculate the symmetric difference, which means S1 minus S2 and S2 minus S1 both. Okay. So actually there are methods defined in Python for sets which can do these things as well. So if you use S1 dot union S2, let's say you have a set S1, and if you do S1 dot union with S2, so here S1 is a set, let's say containing elements 1, 2, 3, and S2 is a set containing elements, let's say 2, 4, 5. Then union function will give you a new set. It will return a new set containing elements 1, 2, 3, 4 and 5. We have already seen the update function. See, update function is an in-place method. Because if you do S1 dot update S2, set1 dot update set2, it will add all the elements of set2 in set1. So it is like union only. But here union is not in a new set. Here set1 is updated, right? So if you use the union function, set1 and set2 will not change. They will be present in memory as it is. But a new set will be created that will be the union of both. And now you can assign it in some other set S3. So if you do this, S1 and S2 will not change, and a new set S3 will be created that will be union of both. But if you want to change the set S1 itself with the union, then you can use the update function. If you use the update function, then S1 will in place change and it will not return a new set. Only S1 will change, S2 will remain as it is. So here is the method that returns a new set, which is the union, and here is the method which is in place, which means it modifies the original set. So that is why union and update are same. Union just returns a new set and these two sets remain unchanged, and update function actually changes the original set itself. So if you do A is equal to 1, 2 and B is equal to 2, 3, and if you do A dot union B, that will give you a new set containing elements 1, 2 and 3. But if you do A dot update B, then A will change to 1, 2, 3. Okay, so that is the difference. Similarly, we have intersection. So if you have to find intersection between two sets, and actually you can calculate this union using this way as well, S1 or S2. This is also same. This also gives you a new set. So this is also same as S1 dot union S2, right? S1 or S2, we already have seen this operator. This also calculates the union only. So this is also same as this, and this is like in place version of that. Similarly, for intersection, you can do S1 and S2. That will give you a new set containing the intersection of these two sets, and you can use the intersection method for set as well. Set1 dot intersection set2. This will create a new set containing the intersection of both the sets. And if you do set1 dot intersection update, intersection underscore update. So update function just calculates the union and update set. But if you do intersection update, it will calculate the intersection of the two sets and it will update set1 as well. So again, it is the in-place method for doing the updation. So if set A is 1, 2, 3 and set B is 2, 3, 4, and if you do A dot intersection B, a new set will be returned 2, 3. Even if you do A and B, again same thing will happen, new set will be created. Here you can do A or B. So you will get 1, 2, 3. Okay. But if you do A dot intersection underscore update, this function B, then A will change to 2, 3. Okay. So just like update, we have intersection update. And we have difference as well. You can calculate the difference between two sets like S1 minus S2. So S1 minus S2 is also okay. But if you don't want to use the operator, you can use set1 dot difference set2 also. That is also okay. That is also valid. And if you do set1 dot difference update, then it will update set1 with S1 minus S2. Okay. So if A is 1, 2, 3 and B is 2, then A minus B is what? You can do A minus B and you will get the new set 1, 3, which means it is out of place. A new set is created. Similarly, if you use A dot difference B, a new set is created. But if you do A dot difference update of B, then A will change to 1, 3. Okay, in the demo we will see all this anyway. And then we have symmetric difference. So if you do set1 dot symmetric difference set2, it is like doing S1 or S2, right? XOR. So the XOR operator, it is symmetric difference, right? S1 minus S2 and S2 minus S1 both. So you can use the symmetric difference function as well. And if you do symmetric difference update, symmetric underscore difference underscore update, that is the function. If you use that, it will update set S1, set 1 with the symmetric difference of set 1 and set 2. So if A is 1, 2, 3 and B is 2, 3, 4, what is A minus B? A minus B is elements of A which are not in B, which is the element 1. And B minus A is what? Elements in B which are not in A, which is 4. And that is why the symmetric difference between A and B is 1 and 4. So if you do A dot symmetric difference B, you will get 1 and 4. You can also write it like this, A or X or B, right? And you can write A dot symmetric difference update B, then it will change A to 1, 4 itself. So that is how you can calculate union, intersection, difference and symmetric difference using the functions as well. We have the bitwise operators as well that do the same thing. And if you want in place updation, then you can use the update function, intersection update, difference update and symmetric difference update. So these are set algebra methods. Okay. Now we have set relationship methods. If you want to check subset and superset, then we can use is subset, is superset and is disjoint functions. Again, we have operators for them as well. If you want to check A is a subset of B or not, so you can use A dot is subset B. It will check is A subset of B or not. Okay. And we have an operator for this. We can write it like this as well. So here less than equal to is nothing but the subset operator. And you can use proper subset also. A less than B. This is proper subset, right? So this is like writing the same statement. It will just check A is a subset of B or not. Similarly, is superset. You can write like this, A greater than equal to B. It will check superset only. And if you want proper superset, you can use A greater than B. But there is a is superset method as well. Is subset, is superset and is disjoint. This is new. If you want to check two sets are disjoint, which means they don't have any elements in common. There are another way of doing it is you can check that A intersection B is empty. You can check that A intersection B is empty. So you can write it like this as well. Length of A intersection B, which means A and B is 0. This is also the same thing, right? It will also check that A and B are disjoint or not. You can write the same thing like this as well. A dot is disjoint B. So this will just tell you that A and B are disjoint or not, which means they must not have any common elements. So here A and B don't have any common elements, so you will get true. Okay. So these are a few functions or methods available for set relationship, checking the relationship between two sets. Now we have seen a lot of methods on sets, how sets work. Why actually do we use sets? So there are some use cases where sets can be used. Removing duplicate element from list. So if you convert a list into set, automatically all the duplicates will be removed. So in any way, like in any point in time in Python, if you want to remove the duplicate elements, you can just convert that iterable into a set. Then all the duplicates will be automatically removed. Okay. And fast membership testing. Again, see, checking whether an element is present in a list or tuple. For example, if I write X in list and if I write X in tuple and if I write X in set, X in set, membership is fastest in sets. Set are the fastest data types. Adding an element, removing an element, checking an element is present or not, everything is fastest in a set. That is because that is how sets are managed. Again, we will see that in the data structures, internally how are sets created, okay? So it is fastest in a set, list is slowest, and tuples is like intermediate, okay? List is the slowest, it is mutable and it takes like the most amount of time. Memory also it takes the most, but set is fastest. So checking membership in a set is very fast. If you want a data type that is very fast and you want to check a lot of memberships, you can use set. Set algebra in real world problem, if you want Venn diagram kind of things, intersection of two sets and union of two sets, difference, symmetric difference, things like that, then you use sets, okay? So this is how you can remove duplicates from a list. If a list contains elements 1, 2, 2, 3, 4, 4, then if you just convert it into a set, all the duplicates will be removed. So only 1, 2, 3, 4 will be present in the set. And if you convert it into the list again, you will get 1, 2, 3, 4. Again, list, like, but the problem is the order is not guaranteed. The order might change. You might even get 3, 1, 2, 4. You might even get 4, 3, 2, 4, 3, 2, 1. Any order might be there. So that is a disadvantage as well. The order might change. But the point is duplicates will be removed. Okay, so if you want to remove duplicates, you can convert it into a set. So that's how you can remove duplicates from a list or a tuple. Okay, now let's look at the concept of mutable sets and frozen sets, what they are. So what happens is a set, when we create a normal set in Python, we do it using the set constructor or using the curly brackets like this. We can pass any iterable, or you can create it using a normal set like this. So both of these create normal set which is mutable. Set data type is mutable. And there is a concept in Python that mutable sets cannot contain mutable objects. A mutable set cannot contain a mutable object inside it. We have seen that a list can contain a list, which means list is mutable and it can contain a list inside it. Even tuples are immutable, and tuples can contain mutable items like list inside them. A tuple can contain a list, right? So a list can contain a mutable or immutable items both. A tuple can also contain mutable and immutable items both. A string can only contain characters and it is itself immutable. So there is a notion, right? Like there are two things. One is itself and one it contains. So a string contains only characters, okay? And it itself, it is immutable. In itself, it is immutable. You cannot change it. List contains both mutable and immutable items. It can contain any item, any heterogeneous type of item. It can be mutable item itself. So you can have a list inside list. You can have a set inside a list. Anything, right? You can have a list or a set inside a list, or you can have an immutable item also inside a list, which means you can have a tuple or a string also. So it can have integer, float, or you can have a list or a set which are immutable, or you can have a tuple or a string which are immutable. Anything, all of them can be present inside a list, and its list itself is mutable. You can change a list once created. And a tuple, okay, and a tuple can also contain any item. So you can write like, we can write it like this. It can contain integer, float, integer, float, boolean, complex, any like whatever data type we have seen: list, tuple, string, set, dictionary. All of them are like, some of them are mutable, some of them are immutable. It doesn't matter. All of them can be present inside a list or a tuple. So even in a tuple, anything can be present, mutable item or immutable item. You can have a list inside a tuple, tuple inside a tuple, a set inside a tuple, anything. But tuple itself is immutable. Tuple itself is immutable, right? List is mutable, tuple is immutable. It can contain any item. Coming to set. Set can only contain immutable items which cannot be changed. That is like, because sets are stored in memory that way. Sets are stored in memory in such a way that only hashable objects, immutable objects are hashable. What is hashable? We will see now. Only hashable objects. Internally it will create a hash. Okay, internally it will create a hash for every item which is there. A hash value should be created. Hash tables or hash values generally as a concept we see in data structures and algorithms. Okay, there we will see that. But you will like, any element in a set must be hashable. And mutable objects are not hashable because they can change. So their hash value will change. So mutable objects don't have a constant hash value. And that's why they are not hashable. Immutable objects, on the other hand, once stored in memory, are forever. They will be remaining as it is. You cannot add, delete or change elements. And hence their hash value will remain constant. And hence every immutable item is hashable, and that can be present inside a set. So a set cannot contain a set inside it. Integer, floating point numbers, they all are hashable. Integer, float, bool, they are all possible. Complex numbers, they are possible. And coming to collections, only immutable collections, which means strings and tuples are possible inside a set. Strings and tuples are possible, but lists are not possible. So if I write it here, in sets, only immutable items are present inside a set, which are hashable as well, which means integer, float, bool, complex, and string and tuple. Only these are allowed. Only these are allowed. These are immutable. Rest everything is mutable. List is mutable. Set is mutable. So you cannot have a set inside a set. A list is not allowed and a set is not allowed. List and set are mutable and hence they are not allowed inside a set. You can only enter a string or a tuple. And set itself is mutable. Once created, it can change. But the elements inside a set must be immutable or hashable. Okay, so that is the difference. So a set is a mutable object itself and unordered collection of unique elements, only unique elements. To maintain consistency and support hashing, all elements must be hashable because we must have hashing, and because of hashing only we can find elements or remove elements very fast in a set because of hashing. Okay, and to maintain hashing and to maintain consistency, only hashable elements or immutable objects are allowed inside a set. An object is hashable if it has a hash method. This is very high level detail, you don't need it. But for now, just understand that a hashable object, when you create it, like the class must have a hash method. And all the immutable objects have a hash method in them. Integer, string, tuple, they all have a hash method. Lists don't have a hash method inside them. So only immutable objects have a hash method inside them. It can be used as a key in a dictionary. So this concept we will see in the next lecture. A key in a dictionary must be hashable. So when we discuss dictionary, we will see that. Or as an element in a set. So a hashable element, an object is hashable if it can be used as a key in a dictionary or as an element inside a set. So inside a set, only hashable objects can be present. Its hash value does not change during its lifetime. Its hash value should not change. And that is why mutable objects are not hashable, because the objects itself can change and hence their hash value can also change. And that is why mutable objects are not hashable. Mutable types like list, set and dict are not hashable. Even dictionaries are mutable. And hence list, set and dictionaries are not hashable. Except these three, all other data types are immutable. Except these three, like if you see integer, int, float, or even complex, bool, or even tuple, str, they are all immutable and they are hashable. But list, set and dict, these three data types are mutable and hence they are not hashable, and these three things are not allowed inside a set. You can never insert a list in a set. If you have a set like this, you cannot say s.add a list containing 3 and 4 because add function takes an element and this element cannot be a list. You cannot add a list inside a set, but you can add a tuple. You can have a tuple containing 3 and 4. You can add this. This is allowed. So now the set will contain 1, 2 and a tuple containing the elements 3 and 4. This is allowed. But a list is not allowed. Similarly, a string is allowed, but a set itself is not allowed. You cannot say s.add a set containing 3 and 4 because you cannot add a set inside a set. You can add a tuple. You can add a string also. This is not allowed. This is allowed. This is not allowed. Sorry. This is allowed. And list is not allowed. And even strings are allowed. Strings are immutable. They are allowed. Immutable objects are allowed. Mutable objects are not allowed. Okay. Inside a set. Because of the hashability. So sets are mutable and that is why immutable objects are not allowed inside them. So for example, if you have an empty set S, you cannot add this element. See, add is different. Update is different. If you say s.update, update is different. Update takes an iterable. So here this is an iterable. So it will add all the elements inside this iterable. It will add 1 and then 2. So it is okay. Right? But if you say s.add list containing 1, 2, so it will try to add this list as an element inside the set, which is not allowed. So this is not allowed. Even if you say s dot update, let's say update, and inside the list you have a list containing 3, 4 and a list containing 7, 6. So what it will try to do? This list will be an iterable, so it will try to add this element, and these elements are list, and list cannot be added. So this will also fail. In an iterable, you cannot have mutable objects. Only immutable objects can be added inside a set. Okay? So this will give you an error, type error, unhashable type list. You cannot create a hash value of list, and that's why you cannot add it. Okay? Here 1, 2 is mutable and unhashable. Python raises an error. But you can add immutable objects like tuples. S.add tuple containing 1, 2. Tuples are immutable and hashable if their elements are hashable. And also, like in a tuple also, there is a catch. A tuple is hashable only if its elements are also hashable. So not all tuples can be added. So let's say a tuple contains a list. If this is the tuple, if this is a tuple T, then you cannot add this tuple inside a set, because this tuple contains a list and it is not hashable. So it is not that all tuples can be added. So only the tuples which contain hashable objects. So if a tuple contains a tuple again, this is allowed. If a tuple contains a string, this is allowed. If a tuple contains a floating point number or an integer, this is allowed. But if a tuple contains a set inside it, or it contains a list inside it, okay, or it contains a dictionary, we will see how to create dictionaries in the next lecture. These are not allowed. These tuples are not allowed. Only hashable objects are allowed, which means tuples can contain only hashable items inside them. Okay. So tuples are immutable and hashable if their elements are also hashable. Okay. Now there is a concept of frozen sets. So this was all about mutable sets. Mutable sets means normal sets. They are mutable, you can change them. But there is a concept of frozen set as well. Frozen set is a immutable set. There is a concept of immutable set as well in Python. It is not a standard data type. It is not a standard data type. Standard data type is just a set which is mutable. But you can create immutable sets as well in Python. That is using frozen set. Frozen set is what? It is an immutable set. Okay, using frozen sets. So how does frozen set work? Let's see. Frozen sets, an immutable version of set. Okay, once created, it cannot be changed. It is like tuple. Once created, you cannot change it. Elements must still be hashable. Still, even in a frozen set, elements must be hashable. It is not that now if a frozen set is an immutable type of object, its items still must be hashable. The concept is same. The only difference is, even in frozen sets, items must be hashable. They must be immutable, which means you can only store tuples or strings or integer floating point numbers like that. You can never store a list or a set inside a frozen set. Okay. But frozen sets themselves are immutable. What does this mean? Frozen set is immutable. What does this mean? Frozen set is immutable. It means it is hashable. It means you can store a frozen set inside a set. Can be stored inside a set. Think about it. You cannot store a set inside a set because set is mutable. It is unhashable. But frozen set is immutable. It is hashable. Still, the items of frozen set are immutable only. The items which are present inside frozen set are immutable and hashable. And it itself is also immutable. And hence it is hashable, and hence you can store a frozen set inside a set. So if you want to store a set inside set, you cannot store a normal set. And hence you must create a frozen set. You can convert a normal set into a frozen set. And then you can store that one inside a set. Because that is hashable. Okay. So you can add a frozen set inside a regular set, or you can even store a frozen set inside a frozen set as well. Okay. Or you can insert it in a regular set as well, or use it as a key in a dictionary also. Okay. This concept, dictionary concept, we will see in the next lecture. Useful when you need set-like behavior but want to guarantee immutability and hashability. If you want to guarantee immutability and hashability and still you want set-like behavior, you can use frozen sets. Okay. So how to create a frozen set? Very simple. Just write frozen set of 1, 2, 3 using a constructor. You cannot create it directly using curly brackets or anything. You have to use the constructor. Constructor is just frozen set. Frozen set. You don't need to add any library or anything like that. Frozen set, and you give it any iterable, and this iterable must be hashable. Even in set, when you write set, when you are giving it an iterable, the iterable must not be hashable. The items in the iterable must be hashable, right? So let's say you give it a list, frozen set and list containing elements 1, 2, 3. That is allowed, but the items inside the list must be hashable or immutable, because only immutable items can be added in a set or a frozen set. So yep. So if you're creating a frozen set of elements 1, 2 and 3, that is possible. When you print it, the output will be frozen set containing the elements 1, 2, 3. The output will be like this. Frozen set containing the elements 1, 2, 3. So the set 1, 2, 3 is displayed, but it is wrapped inside a frozen set. So this is what the output will be. It is a frozen set. And let's say if you have an empty set, you can add a frozen set inside a set. That is allowed because frozen sets are immutable, they are hashable. So you can add a frozen set inside a set, that is allowed. You cannot add a normal set inside a set, okay, because they are not hashable. So if you print S, you will see a set containing a single element, which is a frozen set containing elements 1 and 2, okay. And but if you try to add a normal set inside a set, you will get an error. You cannot add a set inside a set because set is unhashable, okay. So this is what frozen sets are. So this is the difference between the set and a frozen set. Feature mutability, sets are mutable and frozen sets are immutable. They cannot change. Hashable, set is not hashable. Set is not hashable because it is mutable, but frozen sets are hashable because they are immutable. And can it be a dictionary, a key of a dictionary? This again we will see in next lecture. But yeah, only hashable objects can be a key of a dictionary, and hence set cannot be a key of a dictionary, but frozen set can be. Supports add or remove. Sets support add and remove because you can add or remove elements from a set, but from a frozen set you cannot remove or add elements, okay, because they are immutable. Use in nested sets. So you cannot use a set inside a set. So in nested sets you cannot use a set, but you can use a frozen set. You can add a frozen set inside a set. Items inside must be hashable. That is true for both of them. Items inside a set and a frozen set, both items inside them must be hashable. Otherwise you cannot create them, okay. So this is actually true for both of them. For set and frozen set, items inside them must be hashable. This is what set and frozen sets are in Python. So we will see again, we will see in demo like how sets and frozen set work. That will explain you more about all the methods and everything that we discussed. Now let's look at a few examples first. What will be the output of the following code? S is equal to the set containing 1, 2, 3, 4, S dot add 2, print the length of S. So you might think that the length of S is 5 now, but no. If the set contains 1, 2, 3, 4, if you add 2, set still will contain 1, 2, 3, 4 because the set cannot contain duplicate elements. Set cannot contain duplicate elements. If you add 2 again, it will be ignored because 2 is already there. So set will remain 1, 2, 3, 4 and the length of set will be 4. It will remain 4 only even after the add statement. So the answer is 4. Okay. Output is 4. Now moving on to the next example. What is the output of the following code? S1 is equal to 1, 2, 3. S2 is equal to 3, 4, 5. Print S1 and S2. What does the AND operator do? Bitwise AND. It calculates the intersection of two sets. It will calculate the intersection of two sets. Intersection of 1, 2, 3 and 3, 4, 5 is what? The elements which are in both of them. So the only element which is in both of them is 3. So the answer will be a set containing element 3, which is option C. Only the element 3 will be there in the set. So option C. Okay. Now next question, which of the following operations will raise an error in Python? So let's say there is a set containing elements 1, 2 and 3. Which of these operations will raise an error? S dot add 4, 5 list. You cannot add a list inside a set because lists are unhashable. They are mutable and hence they are unhashable. You cannot add a list inside a set. This will give you an error. This will give you an error. The question is asking which of these will give you an error. This will give you an error. S dot update 4 comma 5. Although you cannot add a set inside a set, but you can update it. Update function only cares about iterable. Update function only cares about iterable, and set is an iterable. So it will add all the elements inside the set, which is 4 will be added and 5 will be added. 4 and 5 can be added in the set, and hence this will not give you an error. No error. Right? This will work perfectly fine. S dot add tuple containing 4 comma 5. You can add a tuple inside a set. This will also not give you any error. Right? This will just add the tuple inside the set. S dot remove 10. Now remove function raises an error if the element is not present in the set. 10 is not present in the set, and hence it will raise an error. Remove function raises an error, and hence option A and D are correct. Okay. Moving on to the next example. How many elements are in the set after the following operations? After all these operations, how many elements will be there in the set? So let's see, S is a set, empty set. So S is an empty set currently. Now you say S dot update 1, 2, 3. Update function takes an iterable. Here we have an iterable, so 1, 2 and 3 will be added in the set. 1, 2 and 3 will be added in the set. Then S dot update 2, 3, 4. So 2, 3 and 4 will be added in the set. 2 is already there, 3 is already there, 4 will be added. Now S dot discard 1. Discard 1 means 1 will be removed from the set, and it will not raise an error. Discard function does not raise an error, but it will remove the element. 1 will be removed. S dot discard 5. 5 is not there in the set, so there is nothing to remove. So okay, it will be ignored. Print the length of S. How many elements are there in S right now? 3 elements. 2, 3 and 4. Okay. So this is how you can work with the elements in the set. Update and discard function. 3 elements. Okay, so this is all about sets and frozen sets, how they work, hashability and everything, like the methods which are present for set. And these are a few exercises which you can try on your own. Like this is hands-on Python, like they are all on sets. Try to do them on your own first, and then again like we will see them in demo. So before going to the demo, try to attempt them first. And now let's look at demo on all the set operations in Python.
Okay, now let's see a demo on set in Python. So firstly, let's start with creating sets. How do we create sets? So we create list using square brackets, we create tuples using round brackets, and we create sets using curly brackets. So if I write S is equal to curly brackets, and if I print S, that should create an empty set for me, right? And let me print the size type of S as well. So actually this is not how things happen. If you actually in Python, set and dictionaries both use curly brackets, and if you just write empty curly brackets, it will take it as dictionary. So you cannot create empty sets using just curly brackets. How to do that? The only way to create empty set is using the constructor that we will see. But yeah, if the set is not empty, if it contains at least one element, let's say set containing only one element 1, or it can have a single element, let's say A, string containing A, or let's say for now single element 1, then that is okay. That is okay, there is no ambiguity in that, but you cannot create empty set like this. Okay, so let's print the type of S, and let's also print the length of S. Cool, so that is okay. So if you have at least one element, then you can directly use curly brackets to create sets. And you can have homogeneous type of element, let's say one type of elements, let's say all integers, you can have that. And here the length of the set will be 3, and yeah, but set is unordered. Okay, so the order is not guaranteed. Like right now I got the same order, but it is not guaranteed. So like they can actually come out in any order. Now okay, also the another property of set is it cannot contain duplicates. If you try to insert the same values which are already present again and again, it doesn't matter, it will just ignore them. Let's say this. So still, like, since the only unique values which were present in this set were 1, 2 and 3, and rest all were duplicate, so they were all ignored, and still the length of this set is 3 only. And if when we print the type of it, obviously it is set, and the elements inside it are 1, 2 and 3. All other elements are ignored, you cannot have duplicate elements. And sets can have heterogeneous type of elements, which means different type of elements you can have. 1 and true are same. I will tell you why. They have the same hash value. Let's take something else. Let's take false, and let's take the string hello. So if I print the same things for this string, then this set, then also it will work. So the elements are false, 1, 3.14 and hello. and it can have different type of objects, and all the collections in Python are heterogeneous. Okay, so this is how you can create sets in Python. Now we did not see empty set. If you want to create an empty set, then you will have to use the set constructor. Let's see, if I want to create an empty set like this, I can just use the set constructor, and if I don't pass anything in it, it will create an empty set for me. So if I print the empty set now, it will create an empty set, and I can print the type of it as well, so that you know. Cool. And let's print the length of the empty set as well. Okay, so if you use the set constructor and if you don't pass anything, set and then brackets, it will create an empty set for us. And even when you print it, it does not print curly brackets, because empty curly brackets is for dictionary. So it will print set like this, and the type of it is set and the length is 0. So now inside the set constructor, you can pass any iterable, and that will and the set constructor will convert that iterable into a set. So if I pass, let's say, a list containing elements 1, 2 and 3, then it will convert all these, like it will take all the elements one by one and insert it into a set. So if I print the set now S, it will be a set containing elements 1, 2 and 3. Again, the order is not guaranteed. See here, the order in which we entered the elements was different, and the order in which we got the elements is different. Order is never guaranteed in sets. And you can use any iterator. Basically, let's use the range function as well. We can use the range function, let's say range 1 to 10, and I can insert all the elements from 1 to 10 inside a set. If I print the S now, it will be a set containing elements 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can even use any other iterator. You can use a tuple as well. Let's use a string first. Okay, so if I use a string, let's say GATE, this will also convert it into a set. And here also you can see the order of elements came out to be different. Okay, GTEA, but that's okay. Okay, so this is how sets are created using the constructor and using the curly brackets. Now let's see how we can loop through sets. So first, again, like you cannot actually, we did not see indexing on sets, right? Because let's say we have a set containing elements 1, 2 and 3. So I cannot index a set. I cannot say S of 0, because sets are unordered. They don't have an index. They don't have any index. Positive indexing, negative indexing is not present in sets. It was present in strings, list or tuple, because they were ordered. But sets are unordered. You cannot do that. And hence it will be very difficult to use a while loop and iterate over all the elements of a set. You cannot do that. But we can use a for loop, because sets are iterables. They also give all their elements one by one, but the order is not guaranteed. So if I have a set containing, let's say, some strings A, B, C and then D, okay, then I can use a for loop to iterate over all the elements in a set, but the order will not be guaranteed. Let's say if I print the item, it should work, but the order might be anything. Okay, so C, D, B, A is the order that we are getting here. And again, since set is an iterable, you can use enumerate function as well if you need the index, but it is not exactly index, right? You cannot say that the item is at that particular index, but theoretically speaking, you can use enumerate function on any iterable. So whatever order set is giving, it will think that it is the index, but actually it is not the index of the item, right? So let's say if I write for index comma val in enumerate of S, it should work, but again, like you should not consider it as index because there is no index in sets. Index comma val, so it will say that at index 0 C is present, at 1 D is present. So actually it was not. There is no indexing in sets at all. They are just present. Okay. So this is how you can loop through all the elements of a set. Now let's see mathematical operations on sets which are possible. So mathematical operations on strings, list and tuples were different. You can do plus operator, multiply operator, but they don't work on sets. Plus operator is not, you cannot add two sets. You cannot multiply a number with a set. That all these operations are not allowed. But union, intersection, these are allowed. So if you have a set containing, let's say, elements 1, 2 and 3, and if you do a union with a set containing elements, let's say 4, 5 and 6, union is using the pipe operator, the pipe symbol that we have on keyboard. So this will take the union of all the elements which are present. So let's take some common elements as well so that this statement makes sense. Let's say instead of this set, I do 3, 4 and 5. So it will just give me the union of this set and this set, which means all the elements which are present in set 1 and set 2 both. Okay. And again, if you want intersection, you have to use the AND operator. The AND operator will give you intersection, which means the elements which are common in both of them. And if you want to do set difference, then you can subtract two sets. Again, subtraction is not allowed in other collections, but it is allowed here. So it will just give you all the elements in the first set which are not present in the second set. So only 1 and 2 you'll get. And if you need symmetric difference, which means all the elements in first set which are not in second set, and also all the elements in the second set which are not in the first set, then you can use this up wala symbol in the keyboard, and this will give you XOR, essentially like symmetric difference between these two sets. Okay, then we have the membership operator. Again, the membership operator works on all the collections that we have, all the collections that we have seen so far. It will just check that a particular element is present in a set or not. Again, not in is opposite of in. And the len operator tells us what is the size of a set. So if I give it, let's say 1, 2, 3 and 1. So what will be the size of this set? It will not be 4. It will be 3 only, because 1 is present 2 times. So for this set, the length will be 3 only, because 1 is present 2 times and duplicates are not allowed. It will only count the number of unique elements that are present inside the set. Okay. So this is how the len operator works. And again, min, max and sum work for sets as well. So you can calculate the minimum of a set containing, let's say, A, B, because strings are comparable. So if a set contains A, B and C, you can calculate the minimum of it. And for the same set, you can calculate the maximum element as well. And you cannot calculate the sum, because you cannot add strings like this, but you can calculate the sum of numbers. Okay, so if you apply a sum on strings, you cannot add them like this, but you can calculate the sum of numbers 1, 2, 3, 4. Okay, you'll get the sum as 10. The interesting point here is, if you add 1 here again, the sum still remains 10, because it will only give you the sum of unique elements. Because when you create set, before calculating sum, the set is getting created, and when the set is getting created, this 1 will be ignored altogether. So this is a very important question. What will be the sum of this set? It will not be 11, it is actually 10, right? Cool. So these are all the mathematical operations that we have on sets. Now let's see comparison operations. So we can actually compare two sets, less than, greater than, but they actually calculate superset and subset operations. So if I print, let's say 1, 2 is equal to the set containing elements 2, 1. So yes, they are equal, because when you compare two sets for equality, it will check that exactly same elements are present or not. The order doesn't matter, right? In any ways, in set, order doesn't matter. It should contain exactly same elements. So even if you write 2, 2, 2, 1, 1 here, still they are the same sets, because this set also contains 1 and 2. This set also contains 1 and 2. So they both are actually the same set. And not equal to is opposite of equal to. Now if I say, let's say the set containing 1, 2 is less than the set containing 1, 2, 3, then it will give me true, because this set is actually a subset of this set. It is not checking the length. If I give it 1, 4 is less than 1, 2, 3, then I'll get false, because now the left side set is not a subset of the right side set. It should contain all the elements which are present in the right side. So 1, 2 will work. Even if you do 1, 2, 3, then 1, 2, 3, let's say if you do, then it will give you false, because now they are exactly equal. It should be a proper subset, then only it will give you, okay? But less than equal to if you write, then it will check for normal subset. If you do less than equal to, then it will check for normal subset. Let's say 1, 2, 3 less than equal to. Now even if they are equal, it will give you true, okay? And same for superset. If you do greater than or greater than equal to, it will give you supersets. So let me write them here only. So if I do 1, 2 is greater than 1, 2, 3, it should give you false. And another example should be, if you do 1, 2, 3 is greater than or equal to, let's say, set containing the only element 1, let's say. So it should give you true. Okay, because the left side set is a superset of the right side set. Cool. So this is how you check set, subset and supersets in sets in Python. Now let's see methods that modify the set. Sets are mutable in nature. You cannot index them, so you cannot modify an element at a particular index, but you can add elements in a set. You can remove elements from set. That is all allowed. So you can modify a set once created in place. So if you have a set containing elements 1, 2, 3, if you do set s.add, add function adds a particular element inside a set. So similar function in list was append, because list was ordered. Append means in English, append means what? Appending at the end, right? So append function was there in list, but in set we don't have append because we are not appending at the end. We are adding an element. That's why we have add function. So if I do s dot add 4, now if I print the set, another element will also be present inside it. And in list we had an extend function. Extend function does what? It will extend a list by another list. Extend means again and adding to the end. But sets are unordered, and that's why we don't have an extend function here. We have an update function here. So if you write update function, then it will add all the elements present inside this set in the previous set. So if I do, let's say 3, 4, 5. Now 3 was already present, so that will be ignored, and 4 and 5 will be added, and hence the set will now contain 1, 2, 3, 4 and 5. So this was about adding elements. Now how do we remove elements? So let's say set contain elements 1, 2, 3. So remove is very easy. You just have to use the remove function. Remove function will remove any element which is present inside the set. But remember that you cannot use a remove function if the set does not contain an element. So if I do s dot remove 4, it will give me an error, key error, ki 4 is not actually present in the set, and hence you cannot do that. So remove function only works if the element is already present, otherwise it gives you error. But if you want a different function that does not give an error, that is the discard function. Discard function does not give an error, it will simply ignore. So if you use discard function, again it will delete the element if it is present, but even if the element is not present, it will not give you any error. It will keep on like the program will keep on running. It will just ignore the statement because 4 was not present, it did not do anything, it did not remove anything. So this is the difference between remove function and discard function. And pop function was there in list, and pop function is present in sets as well. But pop function will actually pop function does what? It removes the last element in a list. But here there is no concept of last element, right? So it will just remove a random element. Here 1 got removed, and it returns that element as well, so it got displayed. So it will just remove a random element. It was present at the front, like at the first element, but it got removed. So there is no control. Pop function will just delete a random element from a set. Okay, and then we have clear function. Clear function again works on all tables which are mutable, and it will just clear them up, which means it will just make it an empty set. And it worked for list also, but for tuple we didn't have it because tuples are immutable. Strings were also immutable. For tuple also, for string also we didn't have it, but for sets and list we have it. It will just make it an empty set. Okay. So these are all the methods that modify a set, which means adding elements and remove elements from a set. Now let's look at sorting sets. So dot sort function is not available for sets because again sets are unordered. There is no sense in sorting a set, but you can sort all the elements of a set and take it in a list using the sorted function. Sorted function takes any iterable. Sorted function takes any iterable and it will sort all the elements and give you a list. We saw the same thing in tuples as well. So that will work in a set as well. So let's say a set contains elements 3, 1, 2, 5, 4. And if you just pass it in a sorted, if you want a sorted list out of it, sorted list, then you can use the sorted function. Sorted function always gives a list. So you can print the sorted list now. It will just be a list of all the elements which are present in the set and they are in sorted way. Again, if you convert it into set, then it doesn't matter. If you convert it into set, then again order will change, right? So the order is not guaranteed. Here we got the same order, but it is not guaranteed. So there is no point in sorting a set because set is unordered and you cannot sort an unordered collection, right? And you cannot reverse an unordered collection. And that is why you don't have indexing and slicing in sets. Okay, now let's move over to set algebra methods. We have already seen algebra methods here as well. So you can you can take the union of two sets, intersection of two sets, difference, all these methods were there by using mathematical operators, but we have functions for methods to do that particular task as well. So let's say we have a set containing elements 1, 2 and 3. Again, we have a set containing elements, let's say 3, 4 and 5. And I want to calculate their union. So I can do addition operator as well, but you can actually do s dot union of t as well. So if you do s dot union of t, it will create another set. Again, the original set is not modified. If you use the update function, then it will do the union and it will update the initial set as well. But this is out of place. This is not in place. In place means modifying the original set. Out of place means creating another set. Here we are creating another set. This is the union function, and I can print the intersection of them too, intersection of these two as well, and I can print the difference between these two as well. Difference means a minus b, s minus t is what we are doing here, and we can do the symmetric difference as well. Okay, so these are the exact same things that we did here using and or and subtract and XOR. So the same things happen here as well, and here also the original set was unmodified, there also the original set was unmodified. But if you want to do something in place, then you can do it in place as well. So if s is this and t is this set, and if you do s dot update, update actually is taking union only. We have already seen the update function. Update function does what? It takes all the elements in the second set and adds it to the original set. So it is essentially taking the union of these two sets, but it is in place. So here if you print s will be updated to the union of these two sets. Same way if you want to do intersection as well, let's say again s and t are these, but if you do intersection update function will do what? It will update the original set. And similarly we have difference update function will do what? It will again take the difference and update the original set. And similarly we have what? Symmetric difference update. It will take the symmetric difference and it will update the original set. So it will, like, this is how they work. Okay, so these are all the set algebra methods that are present for sets in Python. Now let's see set relationship methods, which means if you want to check subset or not, then we can use less than, greater than, less than, equal to, greater than, equal to as well, but we have specific functions for them as well. So let's say if we have a set containing elements 1, 2, 3, and we have another set containing elements which is like, let's say it is a subset of this set 1, 2. Okay, so if I print let's say s dot is subset of t. So s is not a subset of t, right? T is a subset of s. So if I do t dot is subset of s, then I will get true, because t is actually a subset of s, and s is actually a superset of t. So I can ask is superset. So is superset function is available, because s is a superset of t, you will get you will get true. And there is another function disjoint as well. Disjoint function tells us ki they are disjoint or not, which means they don't have any element in common. So is disjoint function is there, but they are not disjoint because they have elements in common. If t were different, let's say if t had an element 4, then disjoint would have been true. But here in the original example, they have common elements, and hence is disjoint function gives us false. So this is how we check the relationship between two sets. These are all the important functions which are available for sets in Python. Okay, now let's look at the concept of mutable sets and closure sets. To do that, firstly let us see hashability of object. What do we mean by a particular object is hashable or not in Python? So a set can only contain hashable objects. Hashable means like generally it will firstly calculate the hash value of any object, and then it will store the hash value of the object instead. Okay, so it will index the values based on its hash value. So internally how it works, let's not go there. In DSA we will see how hash values internally work, but yeah, like it will compute the hash value of that object and then only it will store it. But certain objects which are mutable are not hashable, because if they can change, they do not have an hash value. And that is why you cannot calculate the hash value of a list. Lists are not hashable, but other like immutable objects are hashable, which means like normal, integer, float, complex numbers, strings are immutable, they are hashable, tuples are hashable, sets are not hashable, lists are not hashable. And the hash value of certain values are same, which means like internally Python thinks that like 1 as a value and 1.0 as a value, which means floating point 1 and integer 1, and even the complex number, if it does not have any imaginary part, only the real part 1 plus 0j, and even true, the boolean value true, they are all considered as same, and internally their hash value will be same. The hash value of all of these will be 1. Okay, and similarly the hash value of 0, and let's compute the hash value of 0 and the floating point number 0.0, and the hash value of false, and the hash value of let's say 0 plus 0j, which means a complex number which has 0 in both real and imaginary parts, and even the empty string, So the hash value of all of this is again 0, which means that if you add all these objects in a set, they will be considered the same thing and only one of them will be there. Okay, and even if you add all of these values in a set, because their hash value is same, they will be considered the same, and the only single value will be there because they will be considered as duplicates, although they are different, but still, since their hash value is same, they will be considered same for a set. So it means that inside a set, if you add a value 1 or the floating point value 1.0 or even the boolean value true, it doesn't matter, it doesn't matter, and the set will just contain a single value 1 in this case. Okay, so because their hash values is same. So this is how actually it happens. But the hash value of empty, see, I gave you empty string here. For empty string the hash value is 0 only, but for empty tuple the hash value is different. So tuples are interpreted a different way, and for an empty tuple the hash value is different, right? And okay, so this is like printing it. Let's print the hash value of an empty tuple as well. The hash value of an empty tuple is not same as 0, so that will be considered as a separate object. And even the hash value of none is different. None also looks like 0 only, right? But no. So evaluating true false is different. Actually empty tuple and none are also evaluated as false only, but their hash values are different. So hashability is a different concept and evaluating to true false is different. So only like you can check it out in a Python collab, like what all values have, like what different values have what different hash values. Okay, cool. And similarly you can print the hash values of different things. Let's say a string containing my name, what will be the hash value of this is the hash value. Okay, so you can calculate the hash value of anything you want. And even let's say if you want to try to find the hash value of a tuple containing, let's say, elements 1, 2 and 3. Okay, we should create a tuple first. Let's say tuple contains an element 1 and another tuple containing elements 2 and 3 and another string, let's say, containing hello. So this is a tuple and it is hashable, and we will get some hash value. Okay, but if the tuple contains a mutable object, again then it will not be hashable. If a tuple inside it contains a mutable object, let's say a list, so tuples are hashable, but if a tuple contains a mutable object, then it will not be hashable. Then now it will give an error because inside this tuple you have a list and this is not allowed. Okay, so you can use the hash function to check the hash values of different objects, and this is how it happens. Okay, so essentially sets can contain only hashable objects. We say that sets can contain only immutable objects. That is also correct, but essentially the idea is it can only contain hashable objects. So you cannot, and also sets are unhashable. If I calculate the hash value of a set containing an element 1, I cannot do that. Set is also unhashable. Okay, and hence we cannot add a set inside a set. Think about it. Sets can only contain hashable objects, and sets themselves are unhashable, and hence we cannot add a set inside another set, and hence we cannot have nested sets. We can have nested lists, nested tuples, but we cannot have nested sets. Okay, set can contain tuples, but set cannot contain set itself, so that is not possible. So even you can check it out, like if you have a, let's say, an empty set, and if you try to add another, let's say s.add, if you try to add another set inside a set, then it will give you unhashable type set, which is not allowed. But if you want to add a set inside a set, then you have to use frozen sets, because frozen sets are hashable. Frozen sets are immutable. Once created, they cannot be changed. So let's create a frozen set. You can directly say it has a constructor. So constructor is frozen set, and it is a constructor and it can take any iterable it will convert any iterable into a frozen set, and this frozen set is now hashable. It is now hashable. So let me firstly print what f is. F is a frozen set containing elements 1, 2 and 3, and it is hashable now. You can calculate the hash value of f, you will get something. So why is it so? Because it is immutable. Because it is immutable, and hence you cannot add elements. You cannot do f dot add one. Frozen set has no object add. You cannot add elements, update elements. You cannot do that. Okay, so it has a hash value, and hence you can create a set containing a frozen set. That is allowed. That is allowed. Okay, because they are hashable. So if you want to have nested set type of capability, you have to use frozen sets instead of normal sets, because of hashability of frozen sets. Now let's move to set comprehension. So just like list comprehension, we can create set also using set comprehension. Like we can write a for loop for I in range 1 to 10. Let's say I want to add I into I inside a set. I can do that, and if I run this, a set will be created containing the squares of all the numbers between 1 and 9. Okay, so set comprehension also exists. Exactly the same way we had list comprehension, you can have set comprehension as well. Okay, cool. But comprehension does not exist for tuples. Comprehension can only exist for mutable types, because internally it is doing add function or append function, which is not present in tuples because they are immutable. So for tuples we don't have comprehension, but for sets and list we have comprehension. Cool. So this is all about sets. Now let's move to practice exercises which I give you in class. So find common elements between two sets. A very simple question. It is just intersection. We have seen multiple ways in which we can do intersection. So this problem will be a homework. You can try it on your own. Write a program to find the union, intersection and difference between the two sets. Again, we have seen lots of ways to do this. You can try it on your own. You can create two sets and try to create their union, intersection and the difference between these two. And next is using a set comprehension, generate all even numbers between 1 and 20. So that we can do. Let's say S is a set. We have to use set comprehension, and we have to add all even numbers between 1 and 20. So for I in range 1 to 20, but 20 will not be included. So 21, let's add 21. So for I in range 1 to 21, we will add I, but we will add it only if it is divisible by 2, which means if it is an even number. So that's how you can use the set comprehension. If I print S now, it will give me all even numbers between 1 and 20, right? 2, 4, 6, 8 up till 20. So this is how it works. Now next is write a program to determine if two sets are disjoint. So we directly know there is a disjoint function for this. Let's say 1, 2, 3, S2 is a set, let's say 4, 5, 6. Just remember the functions, and to check two sets are disjoint or not, you can directly say that S1 dot is disjoint. Is disjoint function tells me that these two sets are disjoint or not. Cool. Now next is you are given a tuple as an input, and you have to return a set of all unique elements handling nested tuples as well. So we already handled nested tuples and we saw that question in the tuples lecture. Here we just have to add all the elements in the set. In that, like when you see the tuples lecture, there I have solved this problem, but I have created a tuple. Now here you have to create a set, that's all. So again, try this problem on your own. The solution to this is already given to you in the tuples lecture, okay? But here you just have to create a set instead of a tuple. So try these problems as homework. Again, when I give you the collab, I'll give you the solutions to all of them. You can see if you are not able to do it. And for all homework problems in general, homework classroom problems, practice exercises, at least try on your own after watching the lecture. Don't see the solution before trying it on your own. Cool. So this is all about sets, and thanks for watching the lecture. Let's meet in the next lecture. Bye bye.